All right. So let's start our presentation. So today I'm going to be going through in general about technology, our technology, and about the IFWS2 solids, how they work, what the mechanism of this material. It's quite unique. We're the only one who's making it, and there are several very important features of this material. If you have any questions, we can do it two ways. Either you ask me when you got the question, where it's a particular slide, or just you can wait until the end and make sure you're gonna save that question so you're not gonna miss it. I prefer to have it as more as a dialogue. So if you want, just please stop me, ask a question, and we're gonna move forward. So as I mentioned, Nanotech Industrial Solutions is the only company in the world who produces these special spherical particles of tungsten disulfide with controlled morphology and controlled shape. So we control the shape of this material and making them spherical, multi-layer with a hollow core. We're also making them in nanotubes, elongated particles, also with hollow core, with a filled core, and different sizes, but this primarily goes to the polymer matrix, and this is pre-commercial yet, so we're not producing it in the commercial scale. Spherical particles are full scale commercial, really large amounts, and we're producing it for quite a long time. We have around 100+ patents around the globe, covering method of productions of the solid material, as well as the applications of the solid materials in various applications, like oils, greases, coatings, polymers, coolants, metalworking fluids, and so on. We're REACH compliant, ISO certified facility. So everything what is done right way, so you make sure that it's consistent. This is very good video. I'm going to show this video to you. It was done by oil company Total Oil in France sometime in the past in collaboration with the Institute of Technology of Lyon. Really powerful video. Some PhD did this fascinating video under electron transmission electron microscope. Basically, they took two surfaces and compressed the particle, and this video basically shows you several mechanisms how this solid material works. So let me play it, and I'm going to explain what we see. So you see that they're compressing the particle, and this particle is changing the shape. So it absorbs the shock, it getting compressed, and at a certain point, the outer layers of this tungsten disulfide particles getting exfoliated. The moment of exfoliation, that's your friction reduction mechanism. You can notice that actual particles went near to original shape, so it's bouncy. It absorbs the shock and preventing micro-pitting and galling. The actual layers that got exfoliated is very adhesive and it's extremely strong because it's tungsten. So it adheres to the surface, creating anti-wear coating on a surface, as well as reconditioning the surface. So this video, and then this particles again is ready to produce more exfoliated layers like this. And it's going on and on. So this very unique material is unique because of the shape and what the mechanism it can have. So when somebody is telling me that nanotechnology in general is good or is less good, it doesn't, for me, nanotechnology doesn't mean much, because nanotechnology is just technology of something small. So without saying what chemistry of that small material, what is the shape and morphology of that small material, it doesn't mean anything to me. It's the same as to tell that oil is good, but you're not going to put olive oil in your car, probably. I hope not, please, right? So in general terms, we cannot really use general terms and saying nanotechnology is good or is not good. It all depends on a specificity, where you're using it, in what application, what type of solids, because there are thousands of different solids with many different shapes and with many different chemistries. And all of those equally is important. So nano as a word just means something small. It doesn't mean it's gonna work or not in application before we're gonna know specifics of it. So, okay, so what do we do at NIS? We're taking tungsten disulfide, we synthesize it ourselves. So we have our facilities, we have two facilities, two manufacturing facilities, one in Israel, another in US, where we synthesize tungsten disulfide particles with controlled shape and size. Then we're taking these solids and we're dispersing them in various liquids, like in oils, in pastes for greases, in water. Right now we start doing in alcohols. And we're taking those dispersions to then, as a next step, to produce various oils, automotive or industrial, oil additives like a top-ups, greases. We're producing greases under the label of the customer, various different greases. Pretty much at this moment, we have almost 30 greases in our portfolio, but we don't produce greases under finished lubricants. We don't produce under our own brand. We produce finished lubricants under customers' brand because we are primarily additive manufacturers. We're also making water-based fluids and dispersions, which goes into coatings, into metalworking fluid, in a coolants, for example, with the carbon zero initiatives right now around the globe. That's a very good cooling lubricant that can be used as a top-up treatment for HVAC systems, like a large molds, for example, as an example. Any questions? Somebody turn on the microphone. Is it any questions from someone? Okay, then I'll continue. So as I mentioned, this kind of describes the whole process, the flow of how everything is going. So we produce powder as a step number one. We're making dispersion. They look black because tungsten disulfide is black, similar as a graphite or molybdenum disulfide. Then we're making the additives. We're diluting the dispersions in some cases. In some cases we do not. And then we're making also fully formulated product for end users under the brand of the turnkey program. It's a turnkey program. So basically we do everything from A to Z for the customers, labeling, marketing, collateral, everything. And it's their branded product. So the closest material to IFWS2 is molybdenum disulfide. And you probably know this material because it's known for about 60 years as one of the best solid lubricants on Earth. So molybdenum disulfide, tungsten disulfide, spherical tungsten disulfide, they all are from the same family of the materials called metal chalcogenides, where metal is molybdenum or tungsten, and there's a sulfur group as well. And IF stands from inorganic spherical. So because regular molybdenum disulfide, or regular tungsten disulfide, or regular graphite even, they all come in a platelet shapes. They're flakes, they're flat, multi-layer structures, and quite large, around 3 microns. If it's IF, it means it's a spherical, or inorganic fullerene-like, and they also translate it to. So usually molybdisulfide comes in a form of the powder. It's very difficult to deal with. Tungsten disulfide spherical particles we supply in the form of the liquid, much easier to deal with, much cleaner, no airborne material, no hazardous material, and it's much more effective. And here's a very good image. That's how molybdenum disulfide or tungsten disulfide looks. You see it's a flat platelet particles, and our material looks spherical. So you can see this is a micrograph of the agglomerate of the IFWS2, which you can see a bunch of spherical particles lumped together in one agglomerate. But you can see there's small spherical particles there, billions of them. So because molybdenum disulfide or tungsten disulfide regular particles are flat, they usually transfer the load and shock to the metal. and creating micro-pitting, micro-crack, and all of the negative outcome of the shock, specifically on the gear applications. Also, because they're flat and they're quite large, the loading usually between 3 and 8% in a fully formulated product. We can do the same with a fraction of that. Usually, the treat rate of tungsten disulfide spherical particles goes between 0.1 and 2%, depending on the application. It's more eco-friendly, it's more cost-effective. It has a really good extreme pressure protection because of the spherical geometry. And it has a very wide range of applications. Usually, molybdisulfide primarily goes into greases, because in greases there is no sedimentation issue. Because our material is already dispersed, it usually has either no sedimentation or very small sedimentation. And I cannot really definitive answer to that, because we all need to remember that this is not a soluble material, if it makes sense. And I explain you what I mean. Tungsten disulfide, molybdenum disulfide, they do not solubilize in a liquid. And there's advantage to that. And I'll explain you why. Because it doesn't solubilize, it's actual dispersion. So imagine it's not like a sugar in water, it's more like coffee in water. So coffee particle stays in the matrix in a liquid. So you're not solubilizing it, you're making it dispersed homogeneously throughout the liquid. And that's what we do. That's our know-how, how to make sure that dispersion is stable, yet particles are there. When you're solubilizing material like organic matters, like oils and maybe some additives in the oil, they're totally different mechanism how those solubilized additives work. And when you're not solubilizing, but you have actual material, actual active material and ingredient in the system, they start working pretty much immediately. You don't need to have a sacrificial time and period to make those material work and generate tribofilm. And I'm going to show the several slides on this separately. Again, tungsten disulfide spherical particles, or IFWS2, they're becoming a very effective lubricant and should protect from shock, reduce friction wear, increase productivity, minimize downtime, and basically to lower cost of ownership. Because the particles are small and spherical, they fill the cracks and asperities in the on the surface. No surface is flat enough. I mean, if it looks flat, it's not flat on the microscopic level. So material, when it's small, it fills the asperities, it fills irregularities, and make it smooth, which has its own benefits. Actual particles, when they exfoliate, you can see that there's a particle intact, hollow core, multi-layer structure like onion. And when you start damaging it, you produce these sheets or tribofilm of tungsten disulfide. The very important point, and which is counterintuitive sometimes to many users, unlike regular organic lubricants that does not contain solids, the more you damage the particles, the better effect you're going to get. The more tribofilm you're going to generate in the system, the better effect you're going to get. And so this material works the best in applications that require high load, high shock, high temperature, high shear. So anything is demanding applications, anywhere where customers have problems, this material works much better there. And temperature-wise, it can withstand up to 600 degrees, 650 degrees Celsius. Not continuous, but accidental, but it continues, it could be up to 500, 515 degrees Celsius. Of course, the particles are spherical, so they have a rolling effect. And that's also another mechanism how the friction is getting reduced. And a lower friction means lower energy consumption. Again, it all depends on the overall chemistry and the overall application. Right now, I'm talking about fundamental parts. But rolling effect can be visible only and can be predominant, let me rephrase it, only when surface is really flat. If the surface is not flat, is not well prepared, of course, is not going to be a predominant effect for friction reduction, and exfoliation will be predominant effect for friction reduction. But what is the most important feature of this material? It's a extreme pressure. And by extreme pressure, I mean extreme contact pressure, not the hydraulic pressure per se. So this material really absorbs the shock and prevent a material to have a metal-to-metal contact. So it prevents premature failure and prevents microcrack and micropitting and gulling, which is extremely important for many heavy-duty applications. So let me skip several slides, but this one I'm gonna show slides on IFWS2 with other material as a water-based coating or solvent-based coating or paint. So we in a collaboration with another company, we do provide different dispersion in water and in solvent that can be used as a paint, to spray, to brush in on certain surfaces, to create some sort of a solid lubricant / coating on a surface, to prevent to reduce friction, to reduce to get the anti-scratch scratch resistance, to get improve many important points for on a tribological standpoint of view, but also that all translates into the real energy efficiency, downtime reduction, and so on. So here are several applications that it's already used in the high temperature noise reduction for different gears and tooth size, thermal insulation up to 700 degrees C with 2000 degrees C for low volumetric specific heat ratio. It could be spherical heaters, friction scuffing wear, like on a bolt carriers, triggers, fire pins for defense applications, and it's IFWS2 with hexagonal boron nitride and diamond-like carbon. It could be soil resistant and heat resistant applications, like inside diameter of exhaust pipes, ball bearings, metal rings. Also is a dry machining, low friction and flank wear resistance with cutting tools and end mills, and many, many more. So, I mean, there are thousands or even hundreds of thousands of different applications. So we can't cover all of them, but basically, whenever there is a issue related to either heat and wear and friction and shock, all of those applications are really good, like mining, conveying system, conveyor systems, ovens, you name it. All of those are great applications, including, of course, defense. So it will come down to how to apply this material. So it's not like something that works same way everywhere. So there's some understanding of the technology and some understanding of the application requires to apply it right way. So it doesn't mean that this material in any application or same application in any form can be applied. So as an example, so if you're talking about gears, if you want to apply our material on a surface, on a substrate, on a teeth, in a form of the solid lubricant, not in the form of the oil with the particles, there are two different methods. If you want to apply on a gear teeth, those gears has to be cleaned and degreased before, so you can apply particles and create a protective coating initially. Or like it could be a bushing, or it could be cutting tool, doesn't really matter what it is, like, or a piston skirt, or, I mean, doesn't really matter. So the surface needs to be prepared, and you need to know and understand the chemistry on that surface. If it's already coated, and if it's coated, what it's coated with. In some cases, initial coating is really good base for IFWS2, because some of those coatings, if it's a PVD or anodizing, create the porous base, which nanoparticle tungsten disulfide gets into and creating really good solid lubricating film. So all of those points need to be addressed and and understood before actually applying this material. And in addition, when you created certain coating on a surface, then you can apply lubricant, and that lubricant also can contain particles of tungsten disulfide in it. That's a different mechanism. So fundamental, let me show you several slides how fundamentally the particles work and what it provides. So I'm going to show this on a example of water and dispersion of tungsten disulfide in water. So again, it's not apple-to-apple comparison with the same tungsten disulfide spherical particles in oil, but fundamentally water is a good carrier to show fundamental features. So again, we know water is a good coolant, one of the best, right? We know it's not a really good lubricant, but coolant is a really good coolant. But we also know that oil is not a good coolant, is an actual insulator, but it's a good lubricant. So in some cases, specifically in metalworking world, formulators, they found a way to marry together oil and water and creating this two-phase solution to get best from the water and best from oil and creating these emulsions. In reality, they're getting worse from the both worlds. It's neither good coolant, neither good lubricant, and also it's environmentally non-friendly. So what we see that adding IFWS2 with water, we're getting much better cooling properties than just water itself, and really, really strong lubricating properties. And let me show you how does it work. Again, this is as a one of the applications could be as a cooling heat transfer fluid for chillers, heat pumps, energy recovery units, and there are a lot of energy savings right there that customers see. Again, that could be large facilities where it need to be cooled, and commercial buildings, residential buildings, data centers, healthcare, manufacturing, process cooling. I mean, cooling is a really, really big area, and the lower operating temperature is, the more energy efficiency there is. So cooling is a really important thing. In addition to, and this is supplied to in several areas, so Saudi Aramco is one of the customers over there. But let's actually jump to the lubricating part. So that's a cooling part, and then the lubrication part. They're basically both of those creating, addressing kind of similar problem, either downtime or energy efficiency. So now we're going to compare 100% oil with almost 100% of water with some of the material particles. This test called 4-ball EP is a standard ASTM test that measures the film thickness and strength of the lubricating film. I'm sorry, not a film thickness, but strength of the lubricating film. And it measures in a kilogram forces. So the more kilogram the lubricating film can withstand, the better this lubricant is, specifically for demanding applications like gears and many others. Okay, water is not a coolant, of course, so that's something small number. We don't even know what the number is, but we just put 60 because we cannot measure below that. But it doesn't withstand any load. So now we're getting to 100% SN150 oil, which is a group 2 oil. No additives there, but it's just 100% oil. It ruptures the film at 126 kilogram. Now you're adding 99.8% of water and 0.2% of particles. You're already surpassing the 100% oil. So 99.8 water, 0.2 particles, one load stage higher than oil, 100%. And you just keep adding. So 98.7% of water and 1.3% of particle, you're getting to 800 kilogram force, which is basically the maximum of this ASTM standard test. So anything above 800 is called no weld. I can tell you that not many greases or heavy viscosity oils can get to this number. This is very high number, and it's very remarkable number as well. And we're talking about water. And viscosity of this water is like water. It's not like a heavy viscosity, the water-based product that been popped with some water-based polymers to get to substrate viscosity. Looks like, I mean, viscosity-wise looks like water. It doesn't look like water because it's dark, but its viscosity is very close to water and getting 800 kilograms. So what does it really mean? It means that, if you fantasize, of course, that we're saying that there's the possibility to make 100% water-based, heavy performance and high performance lubricant, which is very sometimes hard to grasp when we're saying that the lubricant, and we automatically start thinking about oil. Now, when we're talking about lubricant, we may think of not only oil, but also water. This is a lubricity test, G99, also another ASTM standard test, but a little bit different tribological conditions. We took several lubricants available on the market. So this is water-based lubricant for metalworking applications. And in a green is 100% oil, group 2, and in a blue is a water plus 0.3% of IFWS2. So very important point here that a G99 test, just to understand what it is a test when the pin or ball goes on the same track, on a round track for, here is 15 minutes, and you're measuring the friction. So you see initially with a commercially available water-based lubricant, metalworking fluid, friction goes up. And then, of course, when friction goes up, temperature goes up on the contact area, in the contact area. And when the temperature goes up, you start under this temperature condition, the chemical reaction happening with a certain additives and components in that water-based lubricant, and it starts generating tribofilm, and friction goes down to a certain point. So you can have what I initially said, sacrificial area. It works for some application, but if you're talking about metalworking fluid, it doesn't work that way, because here in G99 test, you have same track. You're working for 15 minutes on the same track. You're running over and over same track. And of course, it generates tribofilm. In a real application, when you're cutting some piece, you all have a fresh surface. You don't have a luxury to spin on the same area. You need to cut and just move on to cut the next area of the piece. So in that application, your friction is going to always stay high. Oil, on the other way around, oil is a very good wetting agent. What I mean by wetting agent, so it really adheres to the surface, not like water. Water is not a good wetting agent. Water you can wipe off. Oil usually you cannot wipe off until you're going to degrease it. So that's why usually you have the quite low friction from the start. With IFWS2, 0.3% at water, you're getting even lower friction from the start. So you don't have to have the sacrificial area. You have several, a lot of data showing how that works in metalworking application, but I'm not sure if for the group it's going to be beneficial. So if yes, let me know. I'll stop on this. If no, we can move forward, and I'll show you different slides. Okay, this is a very interesting test. I'll stop on this one. It's also 4-ball EP test, but what it means here is that sample 4 basically is 0.45% of particles, or sample 3 is 0.27% of particles in water. It has quite high extreme pressure properties. Now, when you getting to sample 5, it is exactly the same as sample 3, but there is a little bit of oil. So you see, in inclusion of some of the oil with the particles drops the extreme pressure performance, which is fine because it's just one of the tests. And this test basically is there are 4 balls with a liquid inside. You're pressurizing it, you're just applying the load, and you're rotating it for 10 seconds. The oil, as I mentioned in the previous slide, is a good wetting agent. So it's creating certain film, oil film on a surface. And for particles to penetrate that film, sometimes is a challenge, and 10 seconds is not enough. So you can imagine Timken test, for example, or any other test where you can have oil, and sometimes particles just do not have enough time to compete with the oil film thickness. So sometimes you have a different, need to have a different condition to particles get on the surface. In a real life, there's not going to be such a problem. And the more polarity you're going to have in the oil and on the surface of, and the more synergistic effect of those additives in the oil it will have with the surfactants that are grafted on a particle's surface, they'll it's going to be more, it's going to be easier for particles to land on a surface first, because everything in a lubrication is about competition for the surface. So whoever gets first on the surface, you're going to get served first. And the surface is a limited area. You don't have endless surface, right? You have a certain limited area, and you need to make sure that particle is going to get that first over there. In a real condition, sometimes it takes a little bit more time, but as soon as particle is going to be worked in on the surface, you know, you're going to start getting all those benefits and effects. But sometimes regular test methods, they do not show it because it's very quick, and you don't know sometimes the chemistry behind the oil you're testing, and there are many other variables you need to take into account. This is very interesting test. It's called Stribeck curve. It basically shows the friction as a function of the load. So, okay, you have certain load, light load, you have certain friction. You're increasing the load, what's going to be your friction at increased load? And there are several regimes, hydroelectric dynamic, mixed regime, and boundary regime. So, and usually this curve looks like this. So it reads from right to left, not from left to right. So on the left side, there is a boundary regime, and on the right side, there is electrohydrodynamic regime, like a light regime. So usually you're competing with viscosity of the lubricant versus actual mix and boundary regime, where it's almost metal to metal contact. But what this test really shows here. So we took sample 5, which has 0.27% of particles, and we run the Stribeck curve at different loads. So at 600 Newton, friction was quite high across. The higher the load, we went to 1000 Newtons to 1200 Newtons, the friction started dropping. And that's a very important point. In a regular lubricant, usually it's the other way around. The more load you apply to the surface, to the system, the higher friction you're going to start getting. But here, because of solid particles, they're not soluble, they're solid in the system, you start damaging the particles more. And the more you're going to damage them, the more tribofilm you're going to start generating. The more tribofilm you're going to start generating, your friction is going to start dropping. Of course, to a certain extent. Here, 1600 Newton friction went up. That means that maybe you need more particles in this like application where there's much higher loads, and that's going to be fine. But that's, you need to apply, you need to see what loading you need based on the system. Maybe you need 0.5%, maybe you need 1%, maybe you need 2% of particles. But the but actual trend is the more you damage the particles, the more effect you're going to get out of it. Okay, topping torque results, we're going to skip that because that's for metalworking applications primarily. So this one is very important. So we see that it's not just a good lubricant, it's also a good coolant. And in water, it's easier to see. In oil, is much harder to see because oil is a insulator. So IFWS2 particles in water, we increase the heat conductivity and heat transfer properties up to 20%. It's a big number. So we're saying it's not a lubricant, it's a cooling lubricant. So it cools and lubricates. There are many different tests and case studies and some reports from customers on the surface finish, on different metals, on the tool life increase up to 2 times, downtime decrease from 3 down to 2 times to 2, and so on. Almost zero friction as a coating at the high loads compared to very high load uncoated surfaces. But what I wanted to show you, yeah, this one is also a very interesting slide showing the anti-galling effect and on a threads. So it can be used as a thread protective coating as well. The threads, if you're talking about big fasteners, there's a lot of contact pressure on a contacts, and that's really good for particles to provide protection for those applications, the threads. Okay, on the grease side. On a grease side, we basically comparing to several were very well-known additives that out there, Lubrizol and High-Tech, made by Lubrizol and Afton Chemicals. So we see that at 2.5%, we can get the same results at 1%, 2.5 times less on extreme pressure properties. Now, when you need to create grease with a higher performance specifications, like for example 500 and over extreme pressure, you need to use 8% of Lubrizol, 550 to 20, and you need only 2%, 4 times less. So here it was 2.5 times less to get kind of okay, like a multi-purpose type of grease. If you need to make a heavy duty grease, you need to use 8% of Lubrizol versus 2% of our additive, which is EMX 7320G. That's our additive, our commercial name for additive for greases. And there are a bunch of different greases that we produce with lithium complex, aluminum complex, calcium sulfonate, urea, polyurea, and many others. And we can go through that, but basically it all depends on applications. So we pretty much across the industry, we do increase the extreme pressure. We're lowering friction and lowering wear and increasing wear resistance. And comparing to molybdenum disulfide, we can get the same results. Whenever molybdenum disulfide can get at 3%, we usually get it at 1%. So we're reducing, compared to molybdenum disulfide based greases, we're reducing the cost of that grease almost 3 times. On the additive side only, not on the grease as a finished product, but on the additive side. And on the grease as a finished product, they're like usually it was 390, we went to 256. As an automotive oil additives, we have 2 products in our portfolio as a top-up treatment for automotive in the automotive applications, and you know them probably. One is AC1000 for gasoline engines, AC1100 for diesel engines. AC1100, besides friction reduction, besides fuel reduction, it also provides, which is important for many mining applications, it also provides very good oil life increase. So we see between 1.5 and 2.5 times oil life increase for AC1100. AC1000 doesn't show this effect because in AC1100 we do have surfactants that also play a role of the cleaner. and detergent. For in dump trucks, there are several of the results that we have with some of our customers in East Europe. So we see that fuel efficiency increased, that's what they're reporting, up to 8.3% per ton of the material. Oil life increased up to 350%. They saw, so their wheels are spinning, they're making more money, they don't stop as often to change the oil or filters and so on. And maintenance interval reduced by up to 300%. So they estimated savings per truck of around $12,000 a year. Again, they're their numbers. We don't challenge the numbers from our customers usually. On industrial oil additive for power generation. So power generation, we're talking about here about same diesel engine from the ship, but stands as a genset on the ground to generate the electricity as a backup. It's very common in Caribbean areas. It's very common for Latin America. So what we see there, so we do supply this material for different engines, for overhauled and not overhauled. For non-overhauled engines, we see a very big increase in the power generation, 42%. Not of the nominal power, but okay, let me rephrase. We cannot make 4 megawatt engine perform at 6 megawatt, of course not. But 4 megawatt engines not overhauled, it actually been performing at 1.6 megawatt. So we've been able to bring it to 3 megawatt, non-overhauled. An overhauled engine, we usually increase at about 10% or 11% of the power generation capacity potential. So again, not above the nominal, because there are none of them working on a nominal power generation. On industrial oil, we have two additives, and IC3100 is the most common. It has a high loading of IFWS2 in it. It's dark gray. It has a really good extreme pressure protection. It reduces coefficient of friction. It also has some anti-oxidation, corrosion inhibiting properties. So this one case study shows the effect of it on IC3100 for Pumpjack gearboxes. And I need to have 1 minute stop because I need to delay my other call. Just give me 1 second. Okay, sorry for that. So on the Pumpjack world, we do supply to in Canada, they see up to 7% current reduction. They see quite significant vibration reduction there, and also operating temperature reduction. So they estimate around $1,700 US savings per Pumpjack on annual basis. So that's all the slides I wanted to share with you. So if there are any questions, please let me know. Let's have a let me answer any questions that you may have. Thank you. No questions?
Hi.
Yes, hello.
Yes, it's Gugu. Thank you so much for the presentation, and it was very informative as well. and well needed on, especially on my side. I just want to check some, I don't have much. You mentioned that on the hydraulic side, were you saying it's not effective, or when you're doing the hydraulic equipment, or what?
No, what I meant is there are two types of pressures. There is hydraulic pressure, there is not much contact pressure, right?
Okay.
And there's a contact pressure called Hertzian pressure as well, another definition of it. There are different types of pressures, not a system pressure overall when you're pressurizing the oil and just and doing some sort of work like in a hydraulic system.
Okay.
So when I'm just talking about pressure in this context, I'm talking about contact pressure. If you're talking about hydraulic, in hydraulic system is a different different tribological condition. There's not much metal to metal contact. Rather, there is hydraulic pressure buildup. Temperature is an issue, and you may see the effect of reduction of temperature, maybe like a shear stability, because all of those are very important for hydraulic oil, right? Again, in hydraulic oil, there's not much metal to metal contact. They're more shearing of the oil. So oil is playing the role of the mechanism, how to transfer the load.
Okay. Yes.
Right? And then as a secondary function is a lubricant as well. So viscosity index is very important there. Shear stability is very important there. Temperature resistance very important there. So usually in a hydraulic oils, customers really want to see low cost because it drips to the ground and it's a loss of the oil. They don't really care about the life of the oil that much. So it's usually it's quite inexpensive oil. So adding additives to that, they may not see the much benefits to the buck. However, we have customers who are using AC 1100 at a 0.75 to 1% in it to see effect that they want to see there. But that's usually the product they're using for hydraulic.
Okay. Last one. There is a customer in Mozambique. I think they're in the gas, is it gas exploration? I'm not sure if you're aware of that. Mozambique is more on the gas side. I think, so I wanted just to check, because I remember they had asked more information on whether the product would it be effective versus the power generation side.
On a power generation, absolutely depends. It all depends not on the general kind of generalized application like power generation, for example. I mean, could be anything, right? In power generation, could be solar, could be wind, could be diesel engine oil, gas, you name it. All of them work very differently or very different conditions. So if you talk about heavy duty cycle, like, if you're gonna take it as a rule of thumb, doesn't matter what application, what industry it is, actual condition is what is very important. If in a condition they have high temperature, high contacts, like so gears, bearings, high load, and I'm talking about like actual load on a surface, not the electrical load, but weight load, shock. Those are great applications. If they don't have those problems, usually they should be fine with any type of oil. So of course, pump jacks, when they have like big gears working like 24/7, that's a great application. Mining, fantastic application. Something is getting pulled or pushed somewhere, a lot of dirt, temperature from minus going to plus. Great, all of those are great. We just need to deliver particles in the right media. So So it could be in the form of the grease, or in the form of the oil, or in the form of the coating, or anything else. That's a mechanism, which is also important. But the rule of thumb is conditions, are conditions.
Okay, okay. With regards to the OEMs, how can we deal with that issue? Because they normally bring it up, which
Yep.
it sometimes becoming an obstacle for us to move forward. How do you always overcome it, you know, on your side?
So there are several points. On OEM, usually there are different type of OEMs. If you're talking about engine manufacturers like Caterpillar, Komatsu, and Cummins, and so on, that's a one story. With the moving equipment, with the stationary equipment is a different story. Usually, moving equipment OEMs are really reluctant to approve or disapprove something. And we work with Cummins, we work with Caterpillar. We have really great relationship with them, by the way. And but we primarily work on greases, for example, or other areas where they don't really have any binding agreements with the oil manufacturers and additive manufacturers like Lubrizol, Afton, Infineum, and so on. So this question becomes very political. So OEMs on a moving equipment, they cannot tell you and cannot tell the customer you can or you cannot use something else what is not approved. They usually do not recommend. They may say you, okay, if something will break, we'll analyze and we'll if it's broken because of whatever you put there wasn't approved, we're gonna be everybody gonna have an issue. But usually that's almost impossible to prove or disapprove. And when we're dealing with it, there are two ways that we deliver the material. Again, we said moving equipment, stationary equipment. Let's actually talk about first moving equipment. When we're coming to the customer, we can deliver material to them in two forms: as a top-up treatment to treat as a top-up already used in a system oil, or as a fully formulated oil or lubricant, right? Both of them is just a methods, doesn't really matter. But if you do not have, if there is no OEM approval, and it cannot be because IFWS2 particles, they are approved by FIA in a racing oil, for example. Racers love that. It's an FIA approved material already, which is huge. But it's not approved yet by OEM because, again, a lot of politics. We don't have like $40 million in 7 years just to do this. But what we do, we come to the customer and say, okay, from the very beginning, very open, if you guys want us to provide you savings and the downtime reduction, we can show it, we can work with you, we can deliver it, because there's tungsten disulfide is known for 60 years as a good lubricant. We're not actually saying something that is not known on this industry. It's not something new information. It's been there for many, many years. There's thousands and thousands of published information on that. So so it was saying to them, if you want us to deliver all those benefits, we'll work with you. If all you need is a blessing from OEM, we cannot give it to you. So you better use what you use. Because maybe you're fine with all those expenses you're incurring. You don't need anything to change. We're not forcing anyone to change anything. So there's actually these 2 points, very important ones.
Okay, no, that's a fair one. Thank you so much.
Yeah, absolutely. Any other questions?
George, thank you very much for Na's presentation. We have a lot of questions, but we can put it to you in writing by email or something like that.
Okay.
We would like to review everything and put the questions as we review and digest all the information.
Sounds good. Yeah.
And we can communicate all the questions to all the team present to the webinar today, and you will get the joint answers.
Excellent. All right. That makes sense. Thank you.
Anyway, thanks for the nice presentation.
Thank you.
Yeah. All
Yes,
right.
thank you.
So, yeah, no more questions, right? Thank you very much, then, everyone. Send yeah. Sugra, I think you want to ask something?
No, George. Thank you very much. I have been hearing this several times. Every time I hear it, it's always very impressive. Thank you.
Thank you.
Yeah.
All right. It was a pleasure.
Thank you,
Enjoy
George.
the weekend.